Okay, kia ora. Good morning, everybody. Thanks for bearing with us as we were just admitting people into our session today. So my name is Emily Lambie. I am a research officer at the Joint Centre for Disaster Research here at Massey University. And with me co-hosting today are my colleagues Marion.
Hello, hi. I'm a research officer here also at the Joint Center for Disaster Research, and we're really excited to have everyone in this room to talk about exciting things.
And Nilani, who's been emailing you all.
Hello everyone, I'm Nilani and I'm a PhD student at the Joint Center for Disaster Research at Massey. Yes, I have been emailing and sending reminders to you all.
So welcome to our TechWeek Cast and Converse series. So we are really pleased with the turnout, so thank you everyone for joining us this morning. This session is one of two, and today we're focusing on networking cities in a changing world. So we really hope that this will be as much of a learning about other projects as it is a connecting opportunity for you all. So make the most out of it and ask as many questions of our panelists as you can. So just quickly, this event has come about through our growing interest in the macro trends and emerging technologies that are shaping our cities. And today we have brought together those who are working in this sphere so that we can start to talk about what the markers of the 2020s will be for building resilient communities. So I'm going to come back to how today will run and what you can expect out of our discussion shortly. But just before we kick off, I want to acknowledge everyone involved in our co-funded Smart Resilient Cities research project and take a few minutes just to ground us in some thinking about what Smart Resilient Cities is working towards. So we have a quick presentation just to get us started. Fantastic. So Smart Resilient Cities is a jointly funded research program with a focus on how we can harness emerging technology for societal resilience. Yep. Great, cool, thank you, Marion. So the driver for this research program is really the wider societal shift of how we interact with our cities, systems and services, which is that emerging technology and data processing tools are changing the cities we live in and the way we live in them. So our big question is really how we can enhance resilient communities. So how might we use innovative data-driven technologies for societal resilience? And what is the technology that will make the difference for people?
So for us, it is about data, sensors, and people, and we kind of group this into three themes. And we want to explore the use of sustainable and low-cost state-of-the-art sensors capable to maintain sensing ability to the city before, during, and after a major disruption. And we're also looking at how are these sensors connected? How do they talk to each other? How do we maintain data? How do we process them? And making sure that they're connected before, during, and after a major disruption. But at the end of the day, all of these technologies are pretty cool, but without the people at the heart of what we do in smart resilient cities, then we just want to really highlight that whatever we develop and whatever we learn, it should be end-user accepted and trusted technology applications to gauge human and infrastructure impact. So we also look at ethical standards, practice priorities, and community-wide opportunities. So these are the key themes of our research program. So hopefully that has grounded of what we are as a research program. And we're just going to run through how today will look like. So we've divided the session today into red time and green time. So red time is just basically we have a set of speakers that will talk about their topics. And then hopefully during this time, you'll try to reserve your questions and bring them to the facilitated discussion, which is the green time. But feel free to use the chat box. So try to put your questions in the chat box, and we'll throw these questions back to our speakers. And so we'll have two to three speakers, and then we'll have a session wherein after each of these speakers to have a discussion among the participants as well as the speakers. And so we have 3 sets today, and then we'll wrap up. And yeah, so that's how today will look like. So anything else? All right.
No,
Yeah.
so we have lots to get through today, and I'm sure there's going to be more questions than answers. So we are recording this, and we will share that with you, so you can come back to the connecting opportunities. And I'm sure we're all, by this point, very familiar with Zoom etiquette, so I won't go through the housekeeping, because I think that we all know what we need to do. So we'll get underway, and I'll hand over to Minh, who's going to be talking to us about dealing with civil emergencies using dynamic agent-based models of cities. So Minh, over to you if you'd like to start sharing.
Hi, thank you. Yeah, firstly, thanks for putting me at first in the line, because I'm teaching at 11, so I'll have to leave shortly after the first discussion, but I'm so excited to be here to talk to you all about what we are doing. Yeah, are you all seeing my screen now? Could you see my screen?
Yes, we can see your screen.
Okay, great. Yeah, thanks. Yeah, so my name is Minh Le Kieu, and I'm from the University of Auckland. I like to share with you today my work on using agent-based modeling and combined with big data to deal with emergencies in city. So if you want to know more about our work and including these slides, you feel free to get into my my personal webpage right there. So we all know that civil emergencies having like devastating impacts on the society and the economy. But it is very hard to know how to best respond to an emergency, because not only that we have to build a clear picture of what's going on, the emerging situation, we also need to predict the near future, predict the short-term future of cities, which is very complex by itself as well. But luckily nowadays we have a lot of big data about individuals, for instance, mobile phone data. And so in this work, we're looking at modeling urban flow using mobile data. We also did use Google travel time data to predict the traffic, to predict the condition of the traffic congestion. But it is actually quite hard. It is actually harder to predict the future of cities, because cities are very complex and has a lot of interacting components. So in order to do that, we use agent-based modeling, basically models of individual agents that interacting with each other. And since we're looking at a lot of individuals' data anyway, that's become a very powerful method to actually model cities and making short-term prediction. However, divergence is a problem in this type of complex model, because the reality is changing rapidly, and the reality is stochastic, is random as well. And so far, there's no method to just quickly update those complex models. You often have to start building up like another model, calibrate them from scratch, which takes a lot of time. And that is exactly what we're trying to do in this project. We're trying to use a method called data assimilation that aim to improve the estimate of the system, improve the near future prediction of the system, given the real-time data that we have at the current time and the models that we develop using historical data. So that's the idea of data assimilation. There's a few models that we have been developing, models of train station, model of buses, and one of the latest one using real data. And you're looking at the Grand Central Station in New York. And we are using agent-based modeling combined with data to give an estimation of where people would be in the short term, and use that for civil emergencies. Yeah, so that's it for me. As you want to know more about our work, feel free to get into my personal webpage right there. Yeah, I'll return back to, okay, thank you.
Wonderful. Thank you so much, Min. So we'll jump straight to Catherine now, who is going to be talking about smart cities and Internet of Things.
Sorry, everybody. For some reason, I can't unmute and share at the same time. So I'm going to try this again. So sorry. Right. Can everybody hear me?
Yes.
Okay. I'm sorry about this. I had it beautifully set up and now I'm panicking and I can't see it.
No worries. Okay.
All right. So here we go. File. View slideshow. I really loved that previous meeting presentation, and I would be very interested in connecting, particularly with the great work that we're doing with the University of Wollongong, the Smart Research Institute, which was founded actually on agent-based modelling, so that was very timely. So I'm going to put my timer on. I've got 5 minutes. So just here we go. Start. I've been asked to talk about IoT and smart cities, so we'll get straight into it. It's really very, very timely. From a city's perspective, there are so many reasons why cities are investing in the Internet of Things. And our experience, so just a little bit of background about myself, I'm actually the co-founder and director of Meshed IoT, but I'm also one of the founders of the Internet of Things Alliance for Australia. And I set up the Smart Cities workstream 4 years ago. For us to investigate the role that smart cities, so that the Internet of Things could play in smart cities. And there's so many diverse reasons why cities are investing in the Internet of Things. Of course, now in this COVID era, we're finding a lot of inquiry around cities asking us how could they use the Internet of Things to bolster job skills and to look at ways in which we can look at post-recovery. So we've got some interesting ideas about that, but it's more than just cities using it for their water metering and their asset management. So it's a very diverse area. But essentially, it's about building digital infrastructure to support what cities need. And we term this low-cost data acquisition for insights about things that matter the most to cities. I've been particularly interested in the idea of IoT for good. So if people have been looking at my LinkedIn posts, I've been posting on IoT for good for about 2 years now. And essentially, there are some really great guidelines adopted by the World Forum on Sustainability and the Internet of Things. And I think this is a great adjunct to the Sustainable Development Goals, which essentially is driving particularly number 11, which is smart connected communities. The fact that cities are really wanting to get more real-time data. They're wanting to build resilience in their communities, and they're also wanting to promote data sharing while respecting privacy. So there's a lot of dynamics going on in terms of smart cities and IoT, but the great thing is that there's some great guidelines pertaining to that. So when we talk about accessible, the Internet of Things, you can't go past the Things Network, and I'm sure many of you have heard of the Things Network. The Things Network is going very well now in New Zealand, and it's an amazing opportunity for universities and communities to basically deploy their own Internet of Things networks and to get data. And it actually, the first project back in 2016 that the Things Network was applied to was actually tracking the radioactivity levels across Fukushima. And that's, if you go to safecast.org, they use the Things Network and low-cost sensors to actually get data pertaining to the radioactivity levels across the community. So, you know, we are very passionate about the democratization of data, and therefore, you know, any capability to use open source and open standards to enable communities to put up their own sensors and for them to actually get hyper-localized data is really about creating better outcomes for people. A really good example here is back in 2016, we brought out one of the founders of the Things Network to Australia. Vinky Geisman, and we ran a workshop, and that led to us deploying now the largest Tier 2 air quality sensing network in partnership with the University of Technology, Sydney. And we've now got this network widely deployed across central Sydney and also the Lake Macquarie district, which is very concerned about the coal dust from the Hunter region. Another example of deployment of what we call citywide participative or collaborative IoT is the Connected Cities Adelaide project, which is a metro-wide Internet of Things network deployed on the Things network in partnership now with 8 local government authorities. And the impetus for them to actually start this project was that 2 years ago they had a record 46.6 degrees one day heat, and they were very concerned about not having hyper localized data. So on that screen you can see a weather station, and that weather station is right next to a community garden. I've got 30 seconds left. The point that I'm just making on this one is that it's really important to realise the role of real-time data with digital twins, and we're now seeing that happening in New South Wales with regards to the digital twin of data coming across you know, activity in that space. And just to finalise, this is my last slide, we've actually been tracking using people counting data the impact of COVID-19 on communities. We're doing a major piece of research with the University of Wollongong, tracking essentially the impact on the social mobility and economic impacts of COVID-19 on communities. And this data has been taken across 180 locations across 26 councils, and it's showing data from the 15th of March to the 1st of July. And what we can see is the impact that when government had mandatory quarantining and social distancing, we are seeing a pickup, but all of you will be well aware what's happening in Australia now with the situation. So we're hoping to use pedestrian flow data to help cities deal with the pandemic post-recovery. And that's it for me.
Thank you so much, Catherine. I really appreciate everybody sticking to the lightning style presentation. So we're getting through this right on time, which is fantastic. I'm going to pass over to Grace now from the Smart, from Christchurch City Council, from the Smart Christchurch project. Fantastic, that's coming up. Wonderful, thank you, Grace. You're still on mute.
You might be on mute from here.
Sorry, I just put my timer on 5 minutes. There we go. So following on those two presentations, mine is a demonstration of data application. So my presentation is about improving resilience through the use of data Sentinel network case study. So this is a case study of our earthquake response system. Hang on. There we go. In the past, the way we estimate earthquake damage is based on magnitude and distance presumed to be equal to damage. Here in Christchurch, before the 2 big earthquakes in 2010 and 2011, we only have 4 GNet sensors, and they are all on the outskirts of the CBD, as you can see them there on the image. But we saw that there was a huge variation in damage. So along line of streets, you'll see some buildings are really badly damaged and some are not. So in 2017, we put a trial of 10 sensors in the CBD, and as you can see, even though within 100 meters between those sensors, there is greater variation in ground shaking. So in 2018, we started a trial in partnership with Canterbury Seismic Instrument, where we installed about 150 earthquake monitoring sensors here in Christchurch. So about 80 of those have been put into traffic signal cabinets, about 30 put in pumping stations, and the rest have been put into council facilities. And because it is a network, some of the private building owners' networks have actually been in the network as well. So in total, around Christchurch, we have about 200 stations available. So we were talking that even the same quake will have a different effect above and below ground assets. So in the buildings, there is a different impact. And then if with the underground facilities, we also have a different impact on that one. So moving on, how are we improving our seismic resilience? So we say here that we are improving community engagement because we provide a real-time area-wide shake map with the summary for the public. We give the community the information that we empower the community by providing them the information that they require. So because it is the output of the network is a building by building information or data. What happens is that, you know, we can look at, if I was a parent, I could look at the area where my child is going to school and I could see that, no, it's not badly impacted. So I don't have to drive now and go and pick up my child from school. And then we are also reducing business interruption. In the past, when there is an event, we tend to evacuate the buildings and then wait until the engineer actually look at the buildings, inspect the buildings and say, yes, it's safe to occupy, go back inside. So we also want to reduce the red zoning of the entire CBD if in case there is a big event. So because we now have data from each building, we can say, yeah, this building can remain open, this building should close. So that reduces business interruption. And then we also improve citywide emergency response. With this one, with our real-time area-wide shake map, responses can be driven in the most effective manners. So we can actually choose which building should be triaged and which building should be cordoned immediately. And in terms of, you know, welfare centers, we could identify which are the welfare centers that we could use. And the last one that I have put there is improve financial performance, because we minimize response actions to those appropriate to the ground shaking. We also minimize council resources or labor diverted to response actions, and minimize council asset downtime. We also are able to overlay the maps of peak ground movement or displacement to show areas of likely damage, such as road and underground assets, so we can identify where are the areas which may be impassable or where there may be water interruption. So that's my presentation.
Thank you. Great. We are right on time for a bit of a green time now. So we're going to open up the floor to our participants to ask our first three speakers questions. I know, Min, you have to take off for a lecture, so just making everybody aware that if you have questions for him and his work, then fire those away now. Because no one's used the chat so far, so I can't see any questions down. So if you would like to ask anything, just feel free to unmute yourself.
Hi, Min. This is Rekha, and I've got a question for you around those agent models. So we've been, deploying AI agents as well, in TNT for water networks and for sensing our smart cities as well. The challenge that we have is around the data and feeding through and creating that self-driven model. Did you face the same challenge around the quality of data? Because in New Zealand, we don't have that much of data to actually improve the quality of our models all the time.
we face the same problem. I actually moved to New Zealand quite recently from the UK, but I didn't find that in the UK there were more data either. So yeah, it's the same problem everywhere.
Okay.
I actually find that in New Zealand the census data seem to be more completed compared to the UK. But obviously, when you look at, like mobile phone data or some kind of data that you can buy from some providers, there are more providers in the UK because you can also look for data in Europe, for example. So I guess it will be always a challenge if you want to directly develop your model with some real data. I would suggest building up the model with some synthetic data first, like some data that you can generate yourself, or some data from overseas to develop the method first. And in the meantime, you can talk to data providers. There are a few nowadays, like on mobile phone data, for example, and look at like census data, look at like household travel survey data, and use them to develop the model.
Cool. Awesome. Thank you.
So we have a question from Gavin for Catherine. How do homeowners with an increasing amount of home sensors contribute to a public resource? For example, if you have a home weather station, but also things like solar generation as a proxy for sunshine, is this sort of information useful, or how can we best share it?
Oh, that's an absolutely fantastic question. And it is very useful. So let me just quickly describe why. In order to get an understanding to ingest into an AI ML engine, you actually need a lot of data. And one of the challenges we have is that traditionally when we look at government and cities is that they've relied on what they call tier 1 process data. So that's data coming off weather stations or earthquake monitors that are provided by the state. But the problem with that is that it is, in terms of the numbers of sensors, they're very limited. And also the time series of when that data is recorded is often very limited. So someone who's got a solar power monitor on their home and they can actually share that data or that application via things such as the Things Network or through a data sharing arrangement, that's very powerful, because what we've seen with, we've got 4 very large urban heat projects happening in Australia at the moment. We've got something like 30 councils participating in it. And essentially what we're doing is that the councils are encouraging the schools and the students and the households to bring their own sensor, connect that into an open data shared model. And what that's doing is it's enabling multiple data points. And so when I was at IBM, before I started Meshed, I was involved in the Watson project, and my background's actually in data analytics. And there's this concept of what we call streaming or pattern data. And what we find is that when you have lots of data points where you can actually do data analytics in flight, what that also does is it helps to remove the anomalies, and so it's critically important that cities are encouraging citizens to do this, but also make no mistake about this. People are doing this anyway. And they're doing it because they're frustrated with the fact that governments and industry are really not listening to their needs. So what we're finding is that in Australia, people are setting up their own microgrids where they're creating their own communities off grid, and they're sharing, they're putting sensors and information on the batteries and things like that. So, I'm really excited about where we are now today, where we've got tools using open standards so that, anybody pretty much out there can participate in this wonderful opportunity.
Well, thank you for that, Catherine. That's really an awesome response. Feel free, anyone, if you want to respond to this conversation. So right now until like 10:50, the floor is open for people to chip in their responses, questions. So feel free to unmute yourself, and if you have anything to add to the discussion, it would be great to get people talking. But for now, we have another question, and I think this is addressed to everyone in the panel. So how do you all believe that the transition to 5G will transform data transfer and processing for your existing applications? And how do you see this being utilized for new applications? So anyone, Min, Catherine, or Grace, what do you think of 5G and how this will affect your existing applications in your respective domains?
I'm happy to start.
Okay, go ahead, Catherine.
I'm going to be very controversial. My background actually is in telco, and I've been in this industry for 30 years. I think what's going to happen is essentially what has always happened, and that is that the ability to leverage 5G is only going to be in the hands of a few. 5G is an extremely expensive technology to deploy, and it is basically what I call use case specific. You don't need 5G to do air quality monitoring, you know, and anybody who tells you that you do, quite frankly, it's not true. You need 5G for no latency capabilities, things such as vehicle to vehicle, autonomous transport. So I think the thing about 5G is I see it complementary, and there's no doubt that it's going to enable greater data flow. But the biggest challenge we have is the business model. Who gets actually access to that data? And Min's point about the mobile operators, we have 58 city councils as our customers, 58. And if I had $1 for every single council who says to me that they are frustrated in the fact that they actually would love to get access to data that's generated off mobile networks, but the cost of getting that data from the operator is absolutely extraordinary. So I think that governments play a very important role here to set some capabilities and some regulatory or some incentives, so that as we deploy these 5G networks, there is an ability for this capability to be more equitable. Look, that's just my view, but it's a view based on 30 years of being frustrated in the telecommunications realm, where in Australia, not so much in New Zealand, probably not, we deployed something that was supposed to change all of this, being the NBN, and it has resulted in the complete opposite. And I really don't see that there's any change in policy that is going to influence that same situation happening with 5G.
Thanks, Catherine. Yeah, awesome answer as always. I live in Australia for a while, and I can totally share the frustration with NBN. From a technological point of view, I'm excited at the opportunity for data to fly in quickly and getting like real-time data in an instance. Because a lot of things that we are doing hangs on the fact that we're going to have real-time data, but actually what we are talking about real-time is not actually real-time. You know, from the time that the data are collected to the time that the data comes to like a database, and the time that the data from the database distribute to our computer is at least a few minutes. So our real-time data is actually kind of like quasi real-time data. But I'm hopeful that with like new technologies like 5G, the part that takes a lot of time, the time when data are collected in the field and then transmit to the database, going to be a lot faster. And hopefully we're going to have like truly data-driven complex models.
Cool. Thanks for your response. And Grace, yes.
Yes, I think it's just going to improve on what we have at the moment, because with 5G, we'll have faster upload and download speed compared to 4G. So it's not saying that it's going to be, it's solving any challenges at the moment, but I think it's more on just improving it. So at the moment, we're using 4G with a lot of our sensors, like for the cameras, but then I suppose it's just going to be faster in terms of upload and the download speed compared to 4G if we have the 5G. And obviously it just offers more connectivity because you have faster speed. And in terms of larger network capacity, 5G will have larger network capacity, which will make it, when there will not be any buffering issues. So yeah, I think that's how 5G is going to help us.
Cool, thanks, Grace. I think we have a question for you.
Yeah, for you, Grace. So I know, so when you're dealing with data, noise is always an issue. So with the seismic sensors, there's a huge amount of noise. How you dealt with this noise when you were building applications?
Did you get that, Grace?
Can you please say that? Can you please ask the question again, Mary?
Yes.
Yeah. When we're dealing with data, the noise is going to be an issue. So I know with the seismic sensors, there's a huge amount of noise generated. So how you dealt with that when you were building applications? The noise means unwanted things that generated by the seismic sensors.
Well, yeah, that's quite interesting, and that's the reason why when we were looking at this, because one of the things that is a challenge is that you get information about a particular building after a seismic event, and say, for example, that building is really badly damaged. You're not going to put that in the public and say, yeah, that building is badly damaged, because you would have some, sort of challenges with making that that information public. So even though we have a network of sensor at the moment, if you are the owner of the building, you're the only one who gets data about your building. Of course, in the future, the consideration is that would the council have any any oversight on that data? We still are trying to navigate our way on that particular one, because yes, if the council has that information, that particular building is damaged, for example, and they're still operating it, what would be the legislative requirements from the council? Do we actually have the authority to say, yeah, you shut down your building because your building is damaged? So at the moment, the way it operates, it's just you get the data for your building. So for us in the council, we have about 130 buildings that we are monitoring on the network. So we get data from all of the building, or all of those 130 buildings, but not the privately owned buildings.
Thanks. Marian has a question. Marian, if you can raise your question here.
Before I start, pardon my dog. He's a little antsy at the moment. Grace, I'm interested in the sensors. I'm a little concerned that people might end up using this data as a proxy for an engineering report. We had enough trouble with this after the earthquake when stickers were put on. If people were allowed in, it didn't mean this building is safe. It meant this building's not going to fall down immediately, get an engineer to check it out. Now, I'm a little concerned that people will get this shaking report and say, phew, my building's fine, it's not shaken very much. But I'm aware that, for example, directionality can be really important. So where the sensor is on the building can actually report less shaking than other parts of the building might. If we're sitting in our office in Christchurch, some computers are east-west, some are north-south. And one earthquake, all the north-south computers, people go, oh, was there an earthquake? My screen was shaking. And the ones who are east-west are going, no, I didn't feel anything. Another earthquake can do it the other way around. So directionality and things like that can make a big difference to the reading that you get. And then I'm just concerned about how this is managed in terms of needing, you can't just use this as a proxy for how damaged the building is unless the building's crumbled down and on the floor. So yeah, just wondering how that bit's going to be managed.
Yeah. So there are two types of reports that come up from the network. So this is the first one is just a simple, it's compared to the NBS standard and what the NBS code. And what it does is just, it tells you there are two thresholds in the system. So first, if it reached the first threshold, which is the serviceability level, you sort of have a visual look, and it might be, some of some chipping on the wall and paint chipping on the wall or stuff. And then you have the next level, which is the ultimate serviceability, ultimate level, which is when you get, when there is a tendency for structural damage. And there are two types of alerts that's being sent out. So the first alert is through the phone of the building warden. And then there is a more detailed report, which has got the structural information that's being sent. It's kind of technical, but apparently when an engineer looks at that report, they could tell what the impact of that particular earthquake is for their building, considering all of the other, combinations that we have, in terms of, the movement, displacements, and stuff like that.
Thanks. We have a follow-up question for Grace again, but this is, I guess, regarding with your relationship with residents and ratepayers. So, as a Christchurch resident, ratepayer, and IoT or home automation geek, does the City Council have any relationship with residents for collection of data? And following on that as well, what sort of data do you think the council would be most interested in from residents?
I think we don't have that relationship yet, and we're working on that in terms of collection of data. I think crowdsourcing of data has not really taken off yet. I'm not sure. I can't identify a city yet that crowdsourcing has been really going very well. But it's something that we are looking at. Because sometimes they say that, well, I remember when we had a project with getting, crowdsourcing information about the state of our roads for cyclists. And then there were a lot of concerns on whether that data is actually reliable. But obviously, when in terms of, the stuff, the data that we would be most interested from residents is that, I would say some actually private owners have their own air quality sensors. So it's something that we could actually put. So we're looking at probably, like for example, with the EQRnet sensors, we have those privately owned and probably put in a network. So if there are any residents that's got air quality sensors, so it might be something that we will be looking into the future of getting another network of air quality sensors. So I think air quality sensor is one of the main things that I would say will be interested from residents.
Thanks, Grace. I think we'll give Grace a little bit of break, and also because we're aware that Min will be leaving soon. So I think Nilani might have a question for me.
Yeah, Min, you were talking about integrating data from mobile networks.
Sorry, you're on mute, Nilani.
Yeah. Sorry, Min, you were talking about mobile data that you have used in your applications. So can you please describe how you obtain them and how you handle the privacy issues?
So the data we got was from the UK, and you remember the figure, it was City of London. And when we received the data, they already aggregated data. So instead of having like individual trajectories where people move and go, we have the counts of people moving from one area to another area of the city. So there's actually not much of privacy issue involved in such type of data. But there's also the downside with that as well, since people obviously need to be very careful about privacy. There's some, the data is actually quite cold. So some of the area in the city which have very low number of people, for instance, like 10, 20, those would be kind of like round up to 100. And that's actually introduced a lot of noise in the data. And that's basically because they don't want any individual person to be tracked from their home address. So I guess there could be a few ways to access the data. Mobile companies now, a lot of them are actually selling the data, and as Catherine said, they are often quite a hefty amount in order to access those data. And once we receive the data, I guess, in my understanding, we should not have such type of like much aggregation in the data. We should instead think of other ways to handle the data. Maybe not like giving real data, but more like synthetic data that follow the same distribution with the data, but not actually showing the real location, timestamp of people living or entering their home address. There are actually now methods in literature, and a lot of them in AI that helps you doing that nowadays, which you can look at. Hopefully that type of data is going to be a lot more popular in the near future. And so having said that, I would like to thank the organizers. I have to leave now for the lectures, and enjoy the rest of the day, everyone.
Thank you so much for joining us, Minh. That was, we really appreciate you making the time, and the rest of our morning speakers. That was fantastic. We've